Hello, good afternoon. Thank you for attending my talk. It is called Android in the Healthcare Workplace, a Case Study. Okay, a little bit about me as we get started here. My name is Tom Richards. I am currently a security consultant at Citadel. There's my Twitter, if someone wants to follow me. That'd be cool. My website, a little bit of a blog, put some stuff up there, some of the vulnerability stuff I work on, and some other projects I got going. Some certs, some offensive security stuff there, Security Plus, GAC, GPen, hacking stuff. So I have 18 published vulnerability assessments to my name. 7 of them have had CVs assigned to them, all open source software. I'm also a developer for Pwnberry Pi, which is a script to install pen testing scripts on the Raspberry Pi. Who's here of the Raspberry Pi? All right. So go look that up. It's on GitHub. And I also have a little Python script called GooFile, which uses Google to look up file types based on a URL. It's in Backtrack since R2. So if you have the base install, you already have it. All right, important note. So yes, I work for a security consulting company. This work that I'm talking about was done prior to my joining the security company. So I'm not violating any NDAs here. I do block out some IP addresses and some product names just because not everything I'm presenting here has been fixed. If you have more specific questions, just come up to me afterwards and I'll be free to talk to you. But just since this is being recorded, I want to keep some stuff off the record. All right, so why this talk? Well, as we know, or hopefully we know, that mobile is a ever-growing and expanding sector of IT. It's just exploding. Everyone has a cell phone at this point, and most people have smartphones, as the talks have alluded to. And companies are obviously looking at ways to capitalize on this growing market. How do we make money on this market? So we see people rushing to the market, or taking previously written applications and porting them to other platforms. And they're essentially making mistakes that web developers were making 10 years ago. And obviously, security is a concern since this is a security conference, and this talk is focused on security issues that I found. All right, so a little bit more of a background. I used to work for a home healthcare company, which think of like visiting nurses. So if you had a need for a nurse to come to your home, whether it was physical therapy or if you have a wound, we are dressed and cleaned and stuff. Generally, we had elderly patients. We didn't have a lot of younger people unless it was physical therapy. So we were dealing with patient information. So HIPAA was a big concern. We had social security numbers, diagnosis, medication lists, addresses, everything you could think of on someone, we would have their information in order to conduct our business. So HIPAA, obviously, is a concern for us and something that we have to follow on. And we need to protect that PHI, that personal health information. We need to make sure that that's not exposed, there's no breaches. I'm from New York, so we don't have extrinsic breach laws like Massachusetts does, but we still have to follow under the federal guidelines for when stuff happens. So generally what people do is tend to worry about encryption. We want to focus on when stuff is in transit and also when the data is at rest. We want to make sure end-to-end that PHI is secure for those individuals so we don't get subjected to millions of dollars of fines. I think there was a couple insurance companies that had like hard drives stolen and were subjected to like millions of dollars of fines for having those hard drives stolen. I also think there was one. It was a company that was being investigated, and the government asked for a certain subset of records on a number of patients. We'll throw a number at like 20. They want, these 20 patient records. Well, what the company did was dumped all of their patient records and mailed them to the government. Yeah, big no-no. So they just violated all those people's PHI, so they got, we were really investigating you, but thanks for violating more things. So they got fined, a lot of money. So we don't want to be fined if you're a for-profit agency. Oh, look, the background. So, home healthcare company, we started on a platform that was Windows-based, so all of our field staff, 90% of our staff was all field-based, so it was all nurses and LPNs and home health aides. The home health aides didn't have devices from us, so just the nurses and the LPNs did. And they would go to your home, perform whatever work they had to do, if they had to check your vitals or make notes or stuff. It was done on a Windows-based laptop. So we knew how to secure Windows-based laptops. And what we did is we transitioned to a mobile platform. So when the person went, they didn't have to go open up the laptop, wait for it to start up, type in their password, open up the software, which was a bear, by the way, god-awful software that we had, and then start doing their work. So we went to a mobile platform. They had Android tablets, Samsung Galaxy Tabs. So they would go, just turn it on, and then fire up the app and go in and do their work. It really made the visit time come down a lot. So more flexibility, and the mobility was, a driving force for us to switch to this platform because it made our core users happier to do their work. So it was a new product. It was originally on Windows Mobile 6, 5 and 6 it was written for. And the company, when they went to a new release, they released it for Android, since Windows Mobile has been declining quite a bit. Does anyone here have a Windows 7 phone or a Windows 8 phone? Yeah, see, that's why. Android or iOS is what I would expect from people in this audience. Yeah, nodding heads. Okay. So they already had a code base, and they just ported it to Android. Quick thing here, we had to deploy 250 Android tablets over the space of a month in order to accomplish the goal of transition to laptop. MDM solutions at the time sucked. The most you could do is put a policy on for passcodes and wiping the devices. Really not much else with Froyo. Froyo didn't have too many APIs. It's gotten better now. With ICS, you got encryption, and you can start to control applications that are on the device, which is pretty cool. But at the time, we had limited solutions, and there was no imaging. So we literally turned on and unpacked and set to our standard 250 devices, which is horrible. If someone wants to make money, find a way to image Android tablets. That is a huge, or just Android in general. That's a big need for people doing these mass deployments. All right, so the software. It was an Android app, so it was an APK. It still is not available in the market. So they didn't have a developer license, they just developed it, and they had it as a download link on the company's website. Kind of good, you couldn't just find it by accident, you have to go looking for the APK if you're gonna do any sort of reversing. So clinicians would sync to get data. So after they set up the device, they would then sync, and it would communicate back to the company's servers, not ours. So it was a cloud service, software as a service. So they would sync back to them, and then we would connect to the host-based app back in our offices to access the information the clinicians were putting up. So the transmission of data and the storage of data were our two biggest concerns. So we brought these up to the vendor, and we said, hey, what are you doing to protect this stuff? They told me they have 128 bits of encryption when we were syncing data, and that the data on the device was encrypted. Okay, so there was some sort of secure container within the application that data was secure. All right, my goal. So I said, are they lying to us? How do we know? I wanted to find a way to compromise this patient information in some way. So I wasn't doing like a complete assessment of the application. I was seeing if I could break it somehow that would get me the patient information and thereby violating HIPAA. All right, so how did I perform the assessment? The Android emulator is a pretty cool piece of software you can install on your PC, and that you could install, it's meant for development, so you can install applications on it. So that gave you easy root access to the device, the file system, and also easy access to watch traffic going in and out. You can just do a Wireshark on your machine and watch the traffic. And at the time, I said, well, what am I looking for on a mobile device? How do I know what's secure, what's not? What am I looking for? What issues exist on mobile? I found that OWASP has a very handy mobile top 10, just like they have the web top 10. What kind of vulnerabilities would you look for on mobile? So that was what I used to guide in looking for the issues with the software. All right. First piece, authentication and authorization. So after you downloaded the application, you only needed two pieces of information to set it up and start working. That was the server name and the agent ID. So the server name was specific to the company, okay? And the agent IDs were 5-digit numerics that happened to be sequential. So in our first round of 250 clinicians, whatever the first one was, the last one was 250 above that. So if you had access to one of those, you could then start stepping through the application as potentially anyone else. Once you have one piece, you can just start going. There was no way to validate an approved device from being configured. Has anyone here been a BlackBerry administrator? Okay, so you know when you go to provision a device, you have the activation code? Yeah, there was no activation code. So if you just had these two pieces of information, you could configure the application and start going through. So I thought, okay, that's a pretty good way to start. Let's see if we can compromise the server name and the agent ID somehow. This was what the setup screen looked like. So you would just input the server and input the user ID and hit validate, and then it would bring you to the screen to enter a password. The user password was locally stored, and there was no complexity requirements. So you could have a password of A or a password of a series of numbers. We used a series of letters for ours. It was 5-character randomly generated passwords is what we used to keep something simple. But that was just locally stored and configured, so there was no other authorization or authentication on that besides on the device. So that's why the agent ID and the server name were critical to compromise any other way, because there was no other step, just those two pieces of information. Data at rest. I said, okay, how are they encrypting this? They were using SQLite, and they had a SQL database that was also backed up to the SD card. Okay, can I open that SQL database? I couldn't. They were using the user's password to AES encrypt that database. So, access to the device could lead to compromise. I didn't explore the option of trying to hack the password that was stored on the device. But the database was at least encrypted both on the SD card, so you can just pop out someone's SD card and just have the whole database. They were doing their due diligence for that. So that was a good first step. So I said, okay, well, at least they're doing something, right? Let's see what else we got going on here. Data in transit. Oh, remember that 128 bits of encryption they said? Well, apparently they do it over port 80 HTTP, which was kind of a surprise to me. I was trying to figure out how they were going to do that. So there was no SSL. They were just using normal HTTP to communicate back to their backend, and they were using post requests to receive the information. So the application would make a post request to the server, and the server would then spit back whatever information it happened to be requesting. Okay, so now I know they're using web protocols, so let's see how it plays as a web app. I didn't get too much into that. Can you guys see that? Okay, so this is an example of the post request going through. Obviously, I've locked out the destination IPs, but you can see that it was just posting to this request, and it was getting stuff back. So through the sync process, it would authenticate the user to the server, and then say, okay, I'm here, start giving me information. And as I did multiple of these per different users, the pattern started to develop, and I saw that it did the same thing every time. As it started to request, I could pull out table names from this thing. I'll show you some of the plain text later, but this was really bad. Sample post request is to show you what is making a post request going through. Side note, if you went to that sync1.thevendor.com/falcon, it showed a form-based logon. Just in the clear HTTP port 80. I tried to connect to it on SSL, and it denied me. So they didn't even have SSL turned on the sync servers. And it was just some web form that they wanted me to log into. At that point, I stopped because I wasn't going to commit any felonies. And also, if you looked at the previous screen, it's hard to see, but what it would do is this mobile device calendar.fal, which .fal was just a rename for an ASP page. They were using ASP, not even ASPX, to process these requests on the back end. it would spit out some of this custom encoding that I found when I was going through the requests. Session handling. There were no cookies. There was no out-of-band management to make sure that this was a legitimate request. So if I took the request and just replayed it back to the server, it would spit me back the information if I was the return IP. So there was no way to authenticate a session. There was no session handling. It was, oh, you want information? Here. Okay, so now the fun part, insufficient transport layer protection. So we had no SSL. So we had the obvious issues with that. So now anyone, if they were in a coffee shop and we're doing a sync, which we actually, in New York, we operate in different counties. And some of the counties had very poor cell reception. Like we're talking between like Albany and Syracuse, where it's really just nothing except a couple small towns. So the cell towers in the hills really hindered 3G connection. So we advised our staff to try and find coffee shops, libraries, any place with open access points they connect to a sink, because their first concern was like, I can't even make a phone call from my house. I have to get out of my house, walk down the end of my driveway, stand underneath the one tree, and then maybe I'll get a bar of service. You know, my daughter has to go up in the attic to the one window and hold the phone out the window and send a text message. You know, like that's what we were dealing with in these areas. So we told people to go to open access points. So what I found is they were using custom encoding on the devices. It wasn't anything that it stood out as like, you know, base 64 or some crazy UTF. It was really custom. They wrote it themselves. And actually some plain text was available in the requests, which was kind of interesting that I started to find out. And again, it was not encrypted at all. So this 128 bits of encryption, I don't know what cryptographer they had that told them that, but that guy should probably be slapped and no longer be allowed to work in cryptography because that just wasn't true. So I was able to, then I started analyzing protocol. I did reverse the APK and start to look at it, but it didn't come out as pretty as I wanted to, so I wanted to see if just looking at it, I could find a way to compromise this information. Okay, so server name identification. Again, everything's in plain text. What do you think the server name was? so really, right there. So as you know, like I said, I was watching like the syncs go through and how they had the pattern, and that thing popped up in the beginning of every single. It was just Rochester. It wasn't Rochester _A. I don't know what the _A was for, but the server name was just Rochester. So that was kind of interesting. Okay. I got half the puzzle now. How do I find the agent ID? So as I started to watch the traffic go some more and analyze like different pieces at the same pieces, different parts at same pieces at the time of the sync between different agent IDs, I noticed this. So this request occurred at the same period of time in the sync as it was going through, and just these two parts are different. So what do you think those two parts are? The agent ID, right? Because that's the only, it's already told them that, hey, I'm Rochester, I want to start talking to the Rochester server. Okay, what could that possibly be? It could have been other things, but it turns out it happened to be the agent ID. So then I tried to figure out all sorts of crazy ways how I'm going to break this. So I started looking through. I'm running low on time, so I'm going to go really fast here. So these were the raw hex of the packet. So I took those two parts that were different, I highlighted them in red, and those are the two parts that were different. When I took that hex and converted it back into decimal, it actually gave me the agent ID. So I didn't even have to go as far as trying to write a way to reverse their protocol. However this worked, it did. And I tested this on a couple different users to make sure I wasn't just crazy. It happened to be happenstance. 5 different users I did this on. At the same point, I was able to pull out this agent ID. Okay, so now I have the server name and I have the agent ID. We know everything's sequential. I could step through my entire organization and get every single person's information, social security numbers, what medications they're on, their doctors, their address, their next of kin, phone numbers, address, everything we have on them, I can now get on every patient. Pretty bad, right? So let's tell the vendor, say, hey, your shit's broken. What are you gonna do to fix it? So I brought it up to my boss, and he said, oh my God, that's scary. Can you like write it up and we'll tell the vendor? Tell the vendor. It took them 2 weeks to get back to me. They were at a conference, and they said, we're gonna look into this. They came back and said they were aware of these issues prior to me reporting them. Yeah. So the first part of them telling me the 128 bits of encryption, yeah, right out the window, lying. Everything else, he told me they had planned on implementing SSL, this was back in 2011, in Q1 of 2012. That's when they wanted to implement SSL. We were the first company to go with this product as a new client, and they were rolling this out to offset all their Windows Mobile. So they're like the fastest growing home healthcare software company in the US, and that's what they were doing. They said, oh no, we were gonna wait to do SSL. Yeah. So their plan. To deal with the authentication issue, they were going to implement setup codes, which they did that right away. After I told them about this, the next training release that came out, which was like 3 weeks later, required setup codes. So the next major product release. So it would randomly generate a code on the server end, and we would have to enter that into the tablet when we were setting up the software. Okay, that's a good first step. SSL took a while. SSL took like 3 months. I had tested it for a while, and it took them a while to put it in. And I still wish I had an older version of the APK so I could show you the differences, but I don't have, the older version of the APK. Okay, so what are we going to do to protect ourselves? My company spent millions of dollars on this software between all the licenses we had to do for the host and the field versions. This wasn't just some simple software that you picked up for a couple $1,000. No, we're talking millions to implement this, through and through with all the training and everything. What are you going to do? What would I have done differently? Well, we already asked them if they were secure, and they outright lied to us. So ask people when you go into mobile stuff, have you had this app independently tested by a software security company? I work for one, but there's also ones out there that do mobile security, that specifically do mobile security. So ask if it's been assessed. Can you get a copy of that report? Or just the findings that they had, and what have we done to mitigate those issues beforehand? Assess the software yourself. Apple is a little more difficult to assess than Android because you have to have an Apple product to do it. So you have to have Macs and then an iPad. Android is a lot easier to come around. You can do Android assessments on Windows, Mac, or Linux. And that's really all you need once you get the APK. So you can start looking at the app yourself. All I did was open up Wireshark. I mean, I did more stuff in the back end, but for accomplishing this goal, I opened Wireshark. That's all I did, looked at it. Or you can yourself have the app assessed by a security company. After we submitted our thing, they said a week after I submitted my abstract to them, they had another vendor that was looking into them have the app independently tested by a company, and they came to the same conclusions I did. So, the other company was doing the right thing before we did. We jumped into the software and ended up finding these issues. Thank you for coming.